For today's quiz, we're going to use a ball. We're going to throw that ball up into the air, and when it gets to its highest point, right up here, right there, the highest point, we simply want to know the acceleration. Here's what the quiz looks like on paper. Please write down your answer and also list how confident you are about that answer. All right, there's a couple ways to think about this problem. First of all, most students like to put the acceleration at the very top is going to be 0. They also, on their drawings, often will draw that the acceleration as the ball goes up is a positive 9.8. That can't be correct. If the ball was accelerating up, it would go faster and faster and faster. So clearly the acceleration is down, even though the ball is going up. When the ball comes down, we certainly know that its acceleration is going to be negative 9.8. There's a few tools that we can use to help us understand this particular problem. And if we were to draw our distance, velocity, and acceleration versus time graphs, we can use that as a tool. That's a time graph, time, distance, velocity, and our acceleration. This is the 0 value. This is positive numbers. 0, positive, more positive, most positive. Negative, more negative, most negative. 0, positive, more positive, most positive. Negative, bigger negative, bigger negative, and so on. And I can end up doing the same thing for each of these. If we think of a ball being thrown up through time, so a ball goes up and then it comes back down. Time goes on. So if the ball was here, the next time it would be a little higher, the next time it would be a little higher, and so on. So if I were to move through time while simply taking the ball up and down, we can kind of see which shape that is going to make for our distance versus time graph. It's not perfect, but I think we get the general idea. It's going to come up and back down. I drew it kind of semicircular, but it's more parabolic. Anyhow, we know that the slope of a line of a distance versus time graph will give us, if that's a tangent line right there, that tangent line right there, we have to bring that down. We know the slope of that tangent line gives us our velocity, aka a derivative. So if we were to take the slope of this, at that point and that point only, we're going to have a slope of 0. I think this is where most students get the misconception that the acceleration at the top would be 0. The velocity is 0 there. In order to find the acceleration, we'll need a few more points on our graph. So this is going to be a very, very, very positive slope. So we're going to have a very positive velocity starting off. Take one in the middle here. That's about a medium positive slope. Therefore, we'd have down below it a medium positive velocity. I could do another one right here. This one is a much smaller positive slope, and this is going to end up translating to having a point here, and then I'll go all the way to the end, and I can see it's a very steep negative velocity because it's a negative steep slope. So if I take that one down here like this, I can say, well, the slope again gives me the velocity, large negative slope, large negative velocity. Do one in the middle here, kind of a medium big at that point. Bring that down, and I can see right away that my velocity versus time graph is going to be a negative constant slope. So the velocity is constantly decreasing till 0, and then it picks up speed negatively. Now, if I simply take the slope of this line, I can get the acceleration. I have a negative, medium, constant slope. Therefore, I have a medium, negative, constant acceleration. And you'll notice this never touches 0. So at the very top of its flight, the acceleration is still that negative value, which happens to be negative 9.8 meters per second squared. Another way to think about why it cannot be 0 at the very top. If a ball were to go up and its velocity were to stop right here at its highest point, and there was no acceleration, if a ball stopped and it didn't accelerate, it would simply hover in space, which we all know that's not going to happen unless you're watching a cartoon. Think about this. The ball is going up in a positive direction. The acceleration is causing it to slow down to a stop, but it never stopped accelerating. So right before it stopped, it was accelerating down, and now, right as it hits instantaneously 0 velocity, the acceleration is going to start pulling it back down. So the acceleration is always negative 9.8 meters per second squared, or negative. So that's your quiz for today.